Hi, good evening, everyone. Uh, Welcome back to Cambridge Guru. Uh, these questions I find very interesting in your complex number as far as A level pure maths 9709 syllabus is concerned, right? And these questions they do come in your external examination. So let us see what this question says that on a sketch of an argon diagram, shade the region whose points represent complex number z satisfying the inequality z plus 2 mod is less than 2 and the imaginary part of z is greater than 1. So basically we have to sketch the common region which is common to these two regions. Z plus 2 mod is less than 2 and imaginary part of z should be greater than 1. So let us quickly draw the argon diagram. Argon diagram is, you already know that it is your imaginary and real axis. So let us assume this is my real part, this is my imaginary part of z, which is normally y-axis, and this is your real part, right? In x and y we say that this is x-axis, right? And z plus 2 less than 2. So what this z plus 2 mod less than 2 is, basically this is a circle, and this I have already told in the lectures. Those who don't have any idea that what this is going on, how we can say this is a circle, then please do watch my lecture videos on the YouTube, right? So this is a circle with center as minus 2 comma 0 and its radius is 2. Okay, radius is 2. So this is basically the radius and minus 2 comma 0 is the center, right? So let us say this is minus 1, this is minus 2, right? And this is your origin, right? So basically this is my center of the circle. So what I have to do is I have to sketch a circle. Let me quickly diminish this. Okay, let me change the color also. Okay, so this is my circle, right? So this is your circle with center as minus 2 comma 0. This point will be the center and radius is 2, so it will touch your origin, right? Now it says that this mod of z plus 2 should be less than 2, meaning that it is asking for the region which is lying inside this circle. Okay, so basically this region denotes mod of z plus 2 should be less than 2, right? So all the points which are lying inside this circle, they all come or they all satisfy this inequality, right? This is the not the required region, but as far as this inequality is concerned. Now second inequality is imaginary part of z should be greater than 1. So basically it is just that your imaginary portion should be greater than 1. So it is a horizontal line, just like y greater than equal to 1 in uh, real numbers, right? So this is basically y greater than equal to 1. So we have to draw a line which is passing through which passes through y equal to 1. Okay, so let me draw like this. Okay, so this is your imaginary line. Imaginary part of z on this line will always be equal to 1 because it is passing through point 0 comma 1. Okay, so all the points which are lying greater than this and all the points which are lying less than z plus 2, right, those will be the required region. That will be the required region. So I'm shading the required region with this green color. Okay, I hope you are with me on this, right? So this is my required region, the green portion. Fine. So this was your first part in this question, that you just have to shade the common region between these two inequalities. Fine, nice and easy. Now second part of this, it says that we have to find out the greatest value of argument of z. for the points which are lying in this shaded region. So whatever region you have shaded, right, there will be infinite such points which are lying inside this green shaded region. So for what values of z, what value of what, or you have to find out the point at which the argument of that complex number should be greatest. Argument mean whatever the complex number is making, whatever angle the complex number is making with the real axis, positive part of the real axis, that angle we have to find out. Basically this you have to find out. Okay, if this is a complex number z, so it is making this angle theta with the positive or the real part of the z, so this theta is called the argument. Then argument should lie between 0 and pi or minus pi, and 0 it cannot be greater than pi, or minus pi, less than minus pi, right? So let us take for an example that if I take the point z here, okay, on the boundary, right, and it is lying somewhere here. Now if you join this point with the origin, okay, you will get one angle like this, right? Let me sketch you also. If you take a point z1 here and you join this with the origin, so this will be your theta, your argument of z, right? So, but this argument be minimum? Can we call this argument be minimum? No, because there is something point which are lying inside this or towards the left of this, okay, and if you join like this, you will get a value theta which is greater than this. Okay, so if you analyze this carefully, you will get a point which is lying at the extreme left of this region, which I have marked with this dot, and let us say this point will be P, right? And now if we join this with the origin, okay, if you join this with the origin, you will get maximum argument, right? This theta will be greatest, right? So this is the point which will give you the maximum or the greatest value of the argument, because all other points will lie towards left of this. Okay, now how to find out basically this argument? So for this we need to convert this equation into real, not real, but using the x and y form. Okay, and we will solve that equation with this y is equal to one line, right? Basically in Cartesian form, if I have to convert this complex number, this line will be y equal to 1, and the equation of this circle can be written as x plus 2 whole square plus y square is equal to 2 square. Okay, x plus 2 whole square plus y square equal to 2 square. Why? Because the equation of a circle with center A and B is given by x minus a whole square plus y minus b whole square is equal to r square, right? And solving this equation with y is equal to 1, I will get 2 points, right? Those two coordinates of x will give me the points of intersection of this straight line y is equal to 1 with the circle. One point will be this and second point will be this. Okay, but I have to choose the leftmost point. So let us solve this equation. So equation of circle will be x plus 2 whole square plus y square is equal to 4, right? And y is equal to 1, meaning x square plus 4x plus 4, putting the value of y here as 1, solving these two equations simultaneously. Which equation? These equations. Okay, so y square is 1 is equal to 4. 4 gets cancelled with this. You get an equation which is x square plus 4x plus 1 is equal to 0. Right, now let me solve it here. This cannot be solved using factorization method. You just have to use b square minus 4ac formula, or you can use the calculator also. So let me use b square minus 4ac quickly. So you will get solution x1 x2 as minus b, which is minus 4 plus minus b square minus 4ac square root over 2, right? So this will be minus 2 plus minus root 3. Okay, two values. Now I am interested in the leftmost value. So one value is minus 2 plus, second value is minus 2 minus, right? So leftmost value will be minus 2 minus root 3. So my required point x coordinate of point P will be minus 2 minus root 3, right? And obviously y is equal to 1 here. So I have now the coordinate of P, which is -2 minus root 3 and 1, right? And if you know this, that if any complex number z is represented by x plus iy, where x is the real part, y is the imaginary part, argument of z is denoted by tan inverse y by x, meaning the imaginary part by the real part. Okay, and since imaginary part here is 1, real part is -2 minus root 3, so my argument of z in this case will be tan inverse y by x, means 1 by -2 minus root 3. Now if I rationalize this, because we cannot keep these surds in the denominator, after rationalizing like this, -2 plus root 3 and -2 plus root 3, this will become tan inverse -2 plus root 3 divided by 1. Okay, so this is just -2 minus plus root 3. So argument of z is this, and basically this is minus 15 degrees. Okay, if I have to write the answer in degrees, right, this is minus 15 degrees. But if to write in terms of, because this is minus 15 and I have to find out the greatest value, so this positive angle I have to give, right? So just subtract this from pi, you will get the required answer. So in terms of radian, this angle will be 11 pi by 12. Okay, 11 pi by 12 radians, because greatest value we have to give, so its magnitude should be positive, its magnitude should be maximum. So 11 pi by 12 will be the required answer. Okay, so that's how sketching of complex number, that's why sketching of complex number is very important, and these type of questions you will encounter in your external exams, right? So that's all for today, and for more such videos, please subscribe, share and like my video. See you next time. Thank you.